What's up, everyone? We are doing topic 4, exponential regressions. Now, regressions enables us to find the line or curve of best fit. In this case, it's going to be a curve because an exponential function, it curves. So let's go ahead and jump into this. So it says a population of single-celled organisms was grown in a petri dish over a period of 16 hours. All right, the number of organisms at a given time is recorded. All right, so this represents hours. Here's my x values represents hours, and here's my y values, right? Or my independent and then my dependent. So at 0 hours, there's already 25 inside the petri dish. At 2 hours, there was 36. At 4 hours, there was 52. Bam, bam, bam. All right, so step 1 says, or letter A says, make a scatter plot of the data on the graph to the right. So you're going to take these points here, and you're going to plot them over here, as I've already done. So kind of pause the video and plot the points. So if you plot them correctly, there should be around here, right? Bam. All right, now that one's done. Check, check. Cool. All right, step 2 says, or letter B says, draw a curve of best fit. Now here's what I'm going to ask. When you draw this curve of best fit, meaning which way would this graph go, I want you to extend it as much as you can, like towards the edge of the graph, because we're going to need to make a prediction, and you'll see in a minute. So again, I'm going to draw it something like this right here. Okay, I'm going to draw it something like that. Okay, now that I have that, oh, also, you guys don't have your graph label, so go ahead and label that too as well. Down here, this x-axis is your independent values. It represents hours, right? Or number of hours. And then your y-axis represents number of organisms. All right, so then it says, predict the number of organisms after 14 hours. After 14 hours. Well, let's just think about this. We need to go to our x-axis, find 14 hours, which is right here, and we're going to follow this up until we hit our curve. And I hit my curve right here. And so I need to predict what is this y value, kind of estimate. So I'm going to go somewhere above 180. 190 is half, so I'm going to say like 185 or something. I'm going to say 185. So using the curve that I made, I'm going to say 185 organisms. That's my prediction based off the graph. Now, here's what this says. Use a calculator to create an equation to match this data and check your prediction. So here's how we're going to do that. We've done regressions before. Now here are the steps for exponential regressions. Step 1, enter the data into stat edit, into this list right here. Please make sure, actually, before you even do this, please reset your calculator, right? Second plus 7, 1, 2. Those reset your calculator. All right, so then you're going to enter your data into these here. X values go L1, Y values go in L2. All right, once you have that, once you have those values put in there, you're going to go to Stat. You're going to scroll over Calculate, and you want to scroll down to where it says Exponential Regression, or EXP-REG. Then you hit Enter 5 times, and bam, you have your well, I'm going to do it with you so you'll see what we're doing. So let's get started. Bam, here we go. All right, so first I need to go to Stat. All right, edit. I need to edit my list. I need to put my values in here. So 0, 2, 4, 6, 8, 10. 0, 2, 4, 6, 8, 10. I would encourage you guys to do this while I'm doing it. So if I'm going too fast, pause the video, do what you got to do, then play the video. All right, so 25, 36, 52, 68, 85, 104. Bam. Now that I have all this listed in here, the next thing I need to go to Stat, go to Calc, and then we want to go down to where it says Exponential Regression. So that's 0 or EXP. All right. So again, mine, I have to do it again. Bam. All right. So yours, again, at the very bottom, yours says Calculate. So that's why you would have to hit Enter 5 times, or you can just scroll down and put Enter. So now I have this here. I have my A value, my B value, and then my R squared and R. You probably don't have R squared yet and R on your calculator. I'm going to show you how to find it in a minute, but and I'll explain that again. But here's what we have. Now, in order for us to have the most accurate, we're going to round to 3 places after the decimal. So when I write my regression, it's going to look like this. 27.049, that's rounding to the 3rd place after the decimal. Parentheses, here's my b value, 1.5 or 1.153, and it stays like that to the power of x. Bam. All right, so this right here, this is a exponential model based off of this data they gave us, right? So this right here will give us, this right here will allow us to predict most accurately what future hours and organisms there will be. So here's what we're going to do. We're going to take this model that we've just found, and we're going to plug in 14 hours to see if we were close, or if I was close to what would actually be predicted based off the model. So I'm going to go here. 2 ways you can do it. One way is you can go to y equals, plug it in, and then go to your table value, or you can normally just type this in, right? Type it all in, plug in 14 to your exponent, and press enter. I'm just going to do this route real quick. So we have 27.049 times, excuse me, I didn't have to do parentheses, but it doesn't matter. So 1.153, close that to the power of x. All right, now I'm going to graph it so I can barely see it. Now I'm going to do second graph. All right, so I want to go to 14 hours. So where's 14? Right here. All right, so looking at that, now I would get 198 organisms using my exponential model, right? This is, I'm just put EXP regression. Using my exponential regression, I got 198. And that was kind of close, but not too close. So this is what the model would give me. So this is all that we're doing today. We're taking these points, we're plugging them in to find the exponential regression, right? This function right here. And then we're answering the questions. I don't know how to turn diagnostics on. The way you turn diagnostics on is you go to second, you go to 0, then you want to scroll down all the way. It's going to scroll down for a little bit until you hit diagnostics on, and you hit enter twice until you see where it says done. All right, so when performing an exponential regression, you will receive our values for a and b, insert them into the exponential function model. You will also receive r and r squared values. Correlation coefficient, the r squared, and the coefficient of determination, the r. Remember, you want these values to be as close to 1 as possible. When you turn this diagnostics on, this is when you will see the r squared and the r. We're only going to focus on the r squared, and we want r squared to be as close as 1 as possible. All right, so pause the video, get this down, then play. All right, so we're going to do only a few examples. Just keep it short and sweet. So let's go ahead and do this. What we need to do is we need to take this data, plug it in our calculator, get the exponential regression, and let's go ahead and write down our correlation coefficient as well. And then we're going to answer this question. What would the value of y be when x is 6? These are questions that you're probably going to see on your star, right? The way they're worded. The value of y when x is 6. So it's saying x is 6. What that actually means is let x equal 6, plug it in. What do you get for y? That's all it's saying. All right, so get your calculator out. Bam. All right, so what we need to do is go back to stat. We need to edit. Now we need to delete all the data that's in here. I'm going to delete this here, delete this here. All right, we're going to type these values in. -2, 2, 5, 7, 9. Go over 5, 27, 92, 20, delete 205.03, enter 461.3, enter. All right, we have this. Now let's go and do our regression. We want to go stat, calculate, and go EXP regression. All right, so now I have my regression. You guys should also see your r squared value and your r. So my r squared, my correlation coefficient, I'm going to write it out right here. I'm not going to round it. I'm just going to write down 0.98. Okay, now this is pretty good, right? The closer to 1 it is the better. And this is a pretty reliable model, meaning I would want to use this model, this function I'm about to write, this regression, to answer like any questions that they would want us to answer. So let's go and write my regression. It's going to be y equals around 3. We're going to go 3 places after the decimal. So 27.049. Yep, stays like that because I can't round up. What is my b value? 1.153. Close that. Actually, this isn't right because that's what we just had earlier, right? Yep, here's why, because my calculator has to do it twice. Don't write that. Sorry, guys. Erase that. Sorry. All right, bam. Do it again. This looks right. I know some of you guys are panicking like, yo, Mr. Styles, that's not what I got. Please don't come yelling at me. Just calm down. Take a chill pill. Just breathe. All right, y equals 11.600 parentheses 1.508 to the power of x. That's your exponential regression. Bam. All right, now that we have this, your correlation coefficient has changed too, right? This is even better than what we have, 0.9, so 0.999. Damn, that's very close to 1, so that's what we want. This is a very reliable function model. All right, now what do we need to do? We need to figure out what would your y value be when x is 6. So we're going to take 6, plug it in here, and then find out. So second mode gets you out of your screen. I have to just go to clear. Second mode will get you out of your screen. All right, so now let's do it. So 11.600 parentheses 1.508. Close that parentheses off to the power of 6. And I'm going to round 3 decimal places after. So let's see. 136.416. And leave it at that. So when your x value is 6, your y value is 136.416, approximately, right? Because we're rounding off, approximately. All right, so that's how you just do it from a basic table. Let's go to a word problem, and then we're going to go to some points. All right, so here's our word problem. So here's what it says. The table shows the number of new stores in a coffee shop chain that opened during the years of 1986 to 1994. Bam. Use x equals 1 to represent this year. Then find the best fitting exponential model for the data. Round 3 decimal places if necessary. Here is what it's saying. When you go and you plug this information into your calculator, I want you guys to pause the video in a minute and do it. When you go and plug it in, you're not going to plug in 1986, 14. What you're going to plug in is 1, 14, 2, 27, 3, 48. That's what you're going to plug in. If you plug in this here, it will be your numbers will be all messed up. So let's just assume that x equals 1, 14, right? And then we'll go from there. So go ahead and pause the video. Go ahead and pause your video and then try to do this yourself and then play the video to check your work. So I'm going to go ahead and do it real quick. Let's see. I should have had this done already. Do I have it done already? I thought I had it done, but I erased it. My bad. All right, so here we go. So I had to calculate, stat. What am I doing? Stat, edit. I need to type in these values. Let's go ahead and do this real quick. It's making this video long. Delete. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, cool. Now I'm going to go over here. What I need to do, 14, 27, 48, 80, 110, 153, 261, 403, 681. Bam. All right, have this. Go to stat, calculate, regression, bam. Oh, gotta do it again. Stat, calculate, regression, bam, enter, bam. All right, so here's what I get. All right, let me move this over so I can write stuff down. All right, using this regression, I'm around 3 decimal places if I need to. So we have y equals 10.596, right? Because I'm rounding up that 5. Parentheses 1.586. Close that to the power of x. Bam. All right, now that I have this, I have my model. All I need to do is answer the question that they want me to answer. What is they want me to answer? So it says, using the equation we just found, what would be the estimated number of stores in 2019? Now let's think about this real quick. I'm not going to plug in 2019 into here. Why? Because remember, we were using 1 to represent this year, 2 to represent this year. So what we need to do, what number would go here to represent 2019? What number would that be? Really, we would just have to subtract this year from this year to figure out how many years have passed, right? That's it. When you subtract that, you would get 33. So 33 years have passed, right, since that. So what you're really going to plug in is 33. So you're going to have y equals 10.596, 1.586 to the power of 33. Let's plug that in real quick. Jeez. All right. So actually, I'm just going to clear that out. 10.596 times 1.5. That's not a 5. 586, close it out to the power of 33. All right, so this is a pretty huge number. So 43,166,515 stores. Whoa, 43 million stores? Jeez, man, jeez. All right, so that's how you would do that. One more, and then you guys will the video end. 6, the graph of the exponential function form, bam, passes through these points. This point, and that point. What is the value when x is equal to -2? Now, I'm not actually, we'll do this real quick. Now, you can still do an exponential regression off this. Just remember, these are points, and points come from a table, right? So I can actually just think about like, yo, these came from a table, right? Where I had 0.05. I had 3, 32, and I had 6, 2, 48. All right, so now you have your table. All you gotta do is plug them into your calculator and then find your regression real quick. So let's do this real quick. It's taking so much time. We can do it. All right, stat, edit, clear. All right, delete. All right, 0, 3, 6, yes sir. 0.5, yes sir. 32, yes sir. 40, 20, 48. Bam. All right, stat, calc, 0. Stat, calc, 0. Enter. All right, so what do I have for my regression? I have y equals 0.5 parentheses 4 to the power of x. Take that bad boy, plug in -2, and see what you get. All right. Second quid, clear. All right. 0.5 parentheses 4, bam, to the power of -2. All right. 0.03125. That's it. That's all you're doing today, guys. Good luck. Please let me know if you have any questions. Your homework for today is 1 and 2 only. 1 and 2. Find the regression, answer the questions, and that is it. Have a good day.